Hello everyone, myself Dr. Suresh, Professor of Biochemistry, and in this video we'll talk about the basic amino acid metabolism, amino acid histidine. So there are three basic amino acids: arginine, lysine and histidine, and some textbook they may consider histidine as one of the aromatic amino acid, but being in basic in nature, so we can take histidine as under basic amino acid. So we'll see how histidine is metabolized in our body, because histidine is semi-essential. Actually, to say it is essential in children, and once after attaining to adult age, it will become semi-essential. So that's the reason histidine is a semi-essential. So what are the functional group it is having? Imidazole. Like tryptophan, in tryptophan is having indole ring, and here histidine is having imidazole ring. So as I told you, it is a semi-essential basic amino acid. The pK value, that means isoelectric pH value, is 6.1. Hence in proteins, histidine is responsible for the maximum buffering action. Okay, so it's basic thing, so that's why it is whatever the buffering actions, like suppose hemoglobin you take or protein buffering actions you take, so because of the presence of more amounts of histidine, the buffering actions are possible because of its pK value 6.1. So now coming to the metabolism of histidine, you see here how once histidine enters in our body, how it will be metabolized. Okay, histidine first converted into urocanic acid. You see this is the imidazole ring here. Okay, and histidine converted to urocanic acid by removing amino group by the enzyme histidase, and urocanic acid is converted into imidazolone-propionic acid, and this imidazolone-propionic acid converted into FIGLU, so by the enzyme imidazolone-propionate hydrolase. And remember this point, FIGLU form immunoglutamic acid. F stands for form, I stands for immuno, G stands for glutamic, and GLU stands for glutamic acid. Okay, form immunoglutamic acid. And here this form immunoglutamic acid has to convert it into form immunotetrahydrofolate. Here the enzyme is tetrahydrofolate form immunotransferase. So here main thing, this form immunotetrahydrofolate is the end product, and at the same time there will be conversion of glutamic acid. So that means form immunoglutamic acid has to convert into two parts, glutamic acid and form immunotetrahydrofolate. Here tetrahydrofolate, that means what is that? Folic acid, B9, vitamin B9, water soluble vitamin B9 is important here. Okay, so tetrahydrofolate. So this tetrahydrofolate is not there. There is no conversion of form immunoglutamate to glutamic acid and form immunotetrahydrofolate. So this two parts not forming in case of B9 deficiency. So there is accumulation of form immunoglutamate, and you can say there is a FIGLU test if in case improper metabolism of histidine. So histidine load test or FIGLU test, you can make out this one. Okay, you have to give histidine, and if there is formation of form immunotetrahydrofolate, is fine. If there is excess amounts of form immunoglutamate in your urine, FIGLU, if you get in urine, so then you can say that there is a defect in like what to say, B9 deficiency. So B9 deficiency, this way they will solve. That is called histidine load test. Histidine load test is useful in making or diagnosing B9 deficiency or folic acid deficiency. So glutamic acid is transaminated to alpha ketoglutarate, which can be converted into glucose. So hence histidine is glucogenic, and histidine is contributed to one carbon pool, and when folic acid deficient, FIGLU is excreted in the urine. So here histidine converted to histamine, the important products which are coming from the histidine, like histamine, so which is important neurotransmitter. So we'll discuss about its functions in next slide. So histamine again degraded to imidazole acetic acid by removing amino group, and also by converting by adding water molecule to form H2O2 by adding the enzyme histaminase, which is a monoamino oxidase. Okay, it is also NADP dependent enzyme. Histaminase or monoamino oxidase, which converts histamine to imidazole acetic acid. So now we'll see the actions of histamine. So what are all the actions this histamine? So in allergic reactions, this histamine starts producing, and what are all its effects? So first we'll see organ by organ. On blood vessels, it causes venous dilation and superficial temporal artery dilation, migraine. Large veins, smaller venules and capillaries are dilated. So vasodilation. Histamine main thing is on blood vessels is vasodilation. And cardiovascular system, it reduces the BP and increases capillary permeability, so to clear the allergens. And heart, it's a chronotropic and inotropic effect on heart. Coronary artery flow is increased. Okay, and smooth muscles, it's a direct stimulant, contraction of bronchial muscles and bronchospasm in lungs. So exocrine glands, it stimulates gastric acid secretion. So histamine causes acidity. So excess of histamine production causes acidity. So there are antihistamines, so which decreases the production of HCl, so decreases the acidity. Certain antigens such as penicillin will elicit IgE antibodies that are fixed on the mast cells. So when the next dose of penicillin is injected, it reacts with the antibodies and degranulation of mast cells to takes place. Histamine and slow reacting substances are released, leads to peripheral vasodilation, fall in blood pressure and anaphylaxis. So it's called anaphylactic shock. So that's the reason in case of allergy people may sometimes die because of this anaphylaxis shock. So antihistamines are drugs which block histamine receptors. They are used to control allergic and anaphylactic shocks. The stimulant effect of histamine on gastric acid secretion is by acting on H2 receptors. Hence H2 receptors antagonists are used in treatment of acid peptic ulcers of stomach. Histidinemia. What is histidinemia? There will be like excessive accumulation of histidine in the blood. So it is an autosomal recessive disease. The deficiency of histidase leads to accumulation of histidine in blood and body fluids and increased excretion of imidazole pyruvic acid in the urine. The clinical features which are including mental retardation and delayed speech development. A low histidine diet may have some effect in improving the condition. Next is urocanic aciduria. So what is this urocanic aciduria? Because it is due to deficiency of urocanase enzyme where histidine is converted into urocane and then it cannot be further converted because of the enzyme deficiency urocanase. So this urocane start excreting in the urine leads a condition urocanic aciduria. Clinical manifestations are minimal. And next is imidazole aciduria. Imidazole aciduria is a dominant type of inheritance. The defect is a transport mechanism in kidney tubules. Cerebromuscular and retinal degeneration may cause blindness. So cerebromuscular and retinal degeneration which leads to blindness. So finally to say 𝐸𝐺 excretion test. So 𝐸𝐺 excretion test, I already told you in the beginning, 𝐸𝐺 excretion test we can make out for the vitamin B9 or folate deficiency. So how would do? So otherwise it is known as histidine load test. About 5 grams of histidine is given 3 times at 4 hour interval. So urine is collected end of 24 hours after the initial dose. So normally less than 30 mg of 𝐸𝐺 is excreted within 1 day. The value is increased in folate deficiency. If there is B9 deficiency, this 𝐸𝐺 is not converted into further form tetrahydrofolate or glutamic acid. So 𝐸𝐺 will be accumulated. So more than 30 mg of 𝐸𝐺 will be excreted. Since folic acid can be directly estimated by ELISA method, the 𝐸𝐺 excretion test is rarely done nowadays. So that's all about histidine and metabolism part of histidine and its related disorders. Thanks for watching. Thank you.